Hello. So we had discussed about the wave equation. Today we are going to solve another example. All right. So this is the example that I will be discussing today. Del 2y, where you are having this wave equation del 2y del x squared equal 1 by 16 del 2y del t squared. And these are the boundary conditions and these are the initial conditions. All right. So if you compare this one with the wave equation del 2y del x squared equal 1 by v squared del 2y del t squared, we actually notice that the value of v is equal to 4. All right. So if we again proceed this one like we usually do by setting y, okay, separation of variables, we will be getting that y, it will be equal to a1 cos kx plus b1 sine kx, and then you will also be having a2 cos omega t plus b2 sine omega t, okay, where the value of omega it's equal to k v, that is equal to 4v, 4k. Okay, so I will keep this one as equation 1. Okay, how exactly do you get all this? Make sure that you refer to the other video that I had discussed about separation of variables and solving the wave equation. Okay, but just know that we will be getting this solution. Now, after getting this solution, we will be using the first boundary condition, okay, using BC1. You will be getting, okay, so the value of x is 0 and time it will always remain as t. So you'll be getting y, value of x is 0, so cos 0 it's 1, so you'll be getting a1, sine 0 is 0, so this term becomes 0, and then you will be getting the value of y, it's actually 0. Okay, the value of y is 0, so you'll be getting this. And upon simplifying, you will actually be getting that the value of a1 it's equal to 0. All right, you can divide this whole thing, okay, because this works for any time t like we had discussed. So you can divide by this one, which may not be equal to 0. Okay, so upon division you will be getting that a1 is 0. Next, what will we do? We will substitute a1 equals 0 over here, okay, substituting in 1. So if we substitute in equation 1, y will actually become b1 sine kx, a2 cos omega t plus b2 sine omega t. So this is what we are having. Next, we will use the second boundary condition. Okay, the second boundary condition, I will just write it down over here. We were having that y to t, it's also equal to 0. So substitute it over here in equation 2. So if we substitute it in equation 2, value of y it's 0, x it's equal to 2, so b1 sine 2x, a2 cos omega t plus b2 sine omega t. This is what we will be having. If we put b1 is equal to 0, right, so this one we will either be having b1 equal to 0 or sine 2x equal to 0. But if we put b1 equal to 0, then this whole thing, this solution that we originally have, it will become 0, all right, which doesn't explain the whole phenomenon. Okay, so this one can be rejected and we are taking this one. Okay, so sine 2x equal to 0, which gives us a 2x equal n pi, okay, where n equal 1, 2, 3, and 2k, okay, k2, k into 2 or 2k, sorry, it should be 2k. So the value of k, it's actually n pi by 2, where the value of n, they are natural numbers. Okay, so actually over here also we will be getting that omega, which is 4k, so will be 2n pi. Okay, so substituting in 2, if we substitute in 2, we will be getting that y, it's equal to b1 sine k, which is n pi x by 2, a2 cos omega, which is 4k, so will be 2 pi t, 2 pi t, okay, 2 pi n t, sorry, and b2 sine 2 n pi t. Okay, maybe I'll write it as n pi. It just looks better. So this is what we are having. Okay, so we have used both the boundary conditions and we actually get this. Next, what we will do is we will multiply this one with this one. So you will actually b1 into a2, they are both constants, so we will write it with a single constant, sine n pi x by 2 cos 2 n pi t. b1 into b2 again will be another constant, which I will replace it with b, sine n pi x by 2 sine 2 n pi t. So this is what we are having, and if you should note down the constant a, it is b1 a2, and the constant b, it is b1 b2. Okay, so take this one as equation 3. Now we have to use the initial condition, so we will actually use initial condition 2 first, okay, because its value is 0, so that's why it will be easier. Actually, this is a process where we have to differentiate first and then use the first initial condition. Okay, so let us first differentiate it. If you remember, the initial condition was del y del t at 0, t it's equal to 0. Okay, so when x is 0, but we actually need to differentiate equation 3. Differentiating 3 partially with respect to t. Okay, so you will be getting del y del t. Okay, so okay, a sine n pi x by 2, this one will behave as a constant, and if you differentiate this one, you will be getting minus 2 n pi sine 2 n pi t plus, okay, and then if you differentiate this one again, you will be getting b sine n pi x by 2. If you differentiate sine, you will be getting cos 2 n pi t. So this is what we are having. Now using initial condition 2, you notice that the value at x equal to 0, it's equal to 0. So substitute x is equal to 0, sine 0 will become 0. Okay, so I may have made a mistake somewhere. Okay, all right, and over here also, sorry, it's actually x0, so sorry. Okay, so sine 0 again is 0, hopefully thankfully it did not change, and over here will be b. Okay, sine n pi x by 2, then you are having this constant 2 n pi cos 0. Okay, since the value of time it's equal to 0, cos 0 it's equal to 1, so you'll be having this, which gives us that b it's equal to 0. Okay, so again we will substitute this one here. Okay, substituting in 3, So if we substitute in 3, we'll be getting this. Okay, since the value of b is 0. Okay, I will actually name this one as equation 4. Okay, so we have finished using boundary condition 1, boundary condition 2. We have also used the initial condition 2. Now all that is left is for us to use initial condition 1. Okay, let me just write it down. What is initial condition 1? Okay, the initial condition 1, if you remember, it was y x 0. So at time equal to 0, the string was kept in this position, 6 sine pi x minus 3 sine 4 pi x. Okay, so using the initial condition 1 over here, so the value of y is equal to this. So 6 sine pi x minus 3 sine 4 pi x, it's equal to this, a. Okay, time equal to 0, so this one will become 1. So all that you will be having is this. Okay, but before using this one, you actually have to superimpose. Okay, so if you superimpose, you will be getting this. So actually after this one, after getting this equation 4, you will superimpose. Okay, after superimposing, then you will be having this. Okay, this one is after superposition. All right, so now that we are having this, we will calculate an by using Fourier series. Okay, so an, it will be equal to 2 by L. Okay, the length of the string over here is 2, integration 0 to L. So it will be 6 sine pi x sine n pi x by 2 minus 3 sine 4 pi x. Okay, and over here we'll be having sine n pi x by 2 dx. So this is what we are having. Okay, just keep in mind this fourth equation. Okay, we will be needing it again. I'm telling you beforehand. Okay, so I'm just noting it down. All right, so okay, so if now we just need to integrate and find out what the value of an. Okay, so this one will be this. All right, so we're getting 0 to 2. Okay, 6 sine pi x sine n pi x by 2 dx minus 3, 0 to 2 sine pi x sine 4 pi x sine n pi x by 2 dx. Okay, how actually do we integrate this one? It is by using the formula. Okay, changing this product. This is a product of trigonometric functions. We will convert it into a sum by using the identity sine A sine B equal half cos A minus B minus cos A plus B. Okay, so that is what we will be using here. Okay, so just let me write it down. Okay, 6, it will be 6 by 2, which is 3. Okay, integration 0 to 2. Over here, it will be cos A minus B. So cos A minus B, which is pi x. Okay, we can actually take common x, pi minus n pi by 2 x minus cos a plus b, which is pi plus n pi by 2x dx. Okay, and over here for the second integral will be minus 3 divided by 2, integration 0 to 2. Again, we will be having cos a minus b, which is 4 pi minus n pi by 2 x minus cos 4 pi plus n pi by 2 x dx. Okay, so this is what we are having. Now we just need to integrate it, and I won't do the integration anymore. I will just write down the answer. Okay, how much is it coming to? For the first integral, you will be getting this. Okay, so for the first integral will be, okay, after multiplying it will become 24 sine n pi divided by pi n square minus 4. And for the second integral will be minus, okay, will be minus 3 into 16, which is 48 sine n pi by pi by n square minus 64. Okay, and over here you should remember that the value of n, they can be natural numbers. Okay, so over here we may be tempted to write this one, that simply an equal to 0 for all n. Okay, we may be tempted to write this one, but we have to be careful. We have to be very careful because n square minus 4, it can be 0. We may be dividing by 0. Okay, so we may be dividing by 0 if, okay, if the value of n it's 2, because 2 square minus 4 will be 0, or n equal to 8. Okay, so this is what we are having. So that is why we will be having this. If we are not dividing by 0, sine n pi, of course it will always be 0. So 0 divided by a non-zero quantity will be 0. 0 divided by a non-zero quantity will be 0. So an equal to 0 for all n belongs to n minus 2, 8. Okay, that is n unequal to 2 and 8. Okay, for all other values which are unequal to 2 or unequal to 8, the value of an, it will be equal to 0. For example, if you put 6, okay, let us say a1 equal 1. Okay, let us say n equal 1, then we will be having a1 sine pi, it will be 0 divided by 1 minus 4, okay, divided by minus 3 pi, okay, which is equal to 0. Okay, similarly, okay, if we calculate this one, it will be 0. So that's why a1 will be 0. Okay, that is a1, it will be 0. a2, we still don't know what the value is. a3 will be 0, a4 will be 0, and so on. a8, we don't know what the value is. All right, so that is what we are having. Okay, but if you remember, the solution was this. Okay, but the solution is actually this one, an sine n pi x by 2 cos 2 n pi t. Okay, so this is what we were having. If you put a1, okay, if you expand this one, a1 will be 0. So all that will be left is this, a2 sine 2 pi x by 2 cos, okay, 2 into 2 will give you 4 pi t, plus, and you will also be having a8 sine 4 pi x cos over here we'll be having 16 pi t. Okay, if we put the value of 8, all other values will be having 0. Okay, so this is what we are having, but this is not a complete solution, because to get the complete solution we will be needing a2 as well as we will be needing a8. Okay, now we look at the initial conditions again. Okay, the initial condition 1, it was y x0 equals 6 sine pi x minus 3 sine 4 pi x. Okay, so substitute it here. Okay, maybe let's name this one as equation 5, I think. Okay, so substituting in 5, we will be having, okay, so y, it will be equal to this value, 6 sine pi x minus 3 sine 4 pi x equal to a2 at time equal to 0, so we will be having sine pi x plus a8, okay, sine 4 pi x. Okay, so if you compare, you will be having that a2, which is equal to 6, and a8 equal to minus 3. Okay, so now we will substitute it here in the solution. We will be getting, therefore the complete solution is y equal 6 sine pi x cos 4 pi t minus 3 sine 4 pi x cos 16 pi t. So this one will be the complete solution. Okay, so over here the main point is that you just have to be careful when dividing by 0. Okay, sometimes we usually make a mistake. Okay, we just because the numerator is 0 doesn't mean that the whole thing will be 0. We have to be careful when dividing by 0. Until next time.